So we were most of the way through problem number 5 yesterday. We still had one thing left to find. What did we still need? We still needed W. So let's go find W in the picture. Where is W? At angle P, right down here. Do we know how big the angle that corresponds to P is? Yes, what's the angle that corresponds to P? Angle L corresponds to P. When you look up at the triangle congruence statement, P is the last letter in this triangle name, L is the last letter in this triangle name. So P and L are corresponding, which means they're congruent because the triangles are congruent. So angle P is congruent to angle L, which means the measurement of angle P is equal to the measurement of angle L. And then what is the measurement of angle P? 5W minus 11. And what is the measurement of angle L? 73 degrees. So we substitute that in, and now we're going to solve this for W. What do I need to do to solve this for W? Add 11 on both sides. That would give me 5W equals what? 84. Then I divide both sides by 5. What is 84 divided by 5? Does that come out to be a whole number? No, so you can either leave it written as the fraction, 84 over 5, or you can write it in its decimal form. What would that be in decimal form? 16.8. So just like the other two, we can write our final answer in fraction form since it's not a whole number, or we can write it in its decimal form. Absolutely beautiful work. All right. Let's go down and look at number 6 now. First thing that I notice about number 6 is right here, they give me a triangle congruence statement. And I'm going to use that triangle congruence statement to mark up these two triangles with all of the corresponding and congruent parts. So we're going to walk our way through this statement. R is the first letter in the name of the first triangle. T is the first letter in the name of the second triangle. So that means angles R and T are congruent. They are corresponding and therefore congruent. So R is right here and T is over here. Those are congruent angles. And then, because these two triangles touch each other, it gets a little bit weird. S is the middle letter in triangle RSV. Well, triangle RSV is this one right here. And so angle S would be this right angle. What does that correspond to on the other triangle? To V. And so what kind of angle is angle V on the other triangle? It would also be a right angle. All right. What is my last pair of corresponding congruent angles? V and S. That seems weird. Didn't we just do V and S? Well, the problem is it's V on this triangle, which would technically be angle RVS. Angle RVS is this one right here. And on the other triangle, this triangle over here, that would be angle TSV. Angle TSV would be this angle right here. And now we're going to mark up our corresponding congruent sides. Segment RS is congruent to segment TV, first two letters. RS is congruent to TV, right there. Last two letters, SV and VS. Well, SV and VS, that's this segment right here. That segment belongs to both triangles, right? It's the right edge of the left-hand triangle and the left edge of the right-hand triangle. It is congruent to itself. So I'm going to mark it with a congruence mark. Because they share that side, it is congruent to itself. It is the same size as itself. There's one more pair of sides that are corresponding and therefore congruent. What is that pair of sides? RV and TS. RV is first and last letter here. TS is first and last letter here. So RV is congruent to TS. We have been tasked now with finding X and Y. So let's look first for X. Do you guys see an X anywhere? Yeah, where's X? Angle T right here. Do we know how big the corresponding angle is? No. So I'm going to have to stay inside this triangle right here. And I have to find a way of figuring out X. Do I know how big the other two angles are inside that triangle?
One of them.
I know how big one of them is, 90. Do I know how big the other one is? Look carefully.
Oh, nice.
Well, I know how big the 90-degree angle is. The other one is 78 degrees. How do we know? Yeah, this angle right here, remember, is congruent to this angle. And we're told that that angle is 78 degrees. So this angle here is 78 degrees. So I would say the measure of angle T plus the measure of angle TSV plus the measure of angle TVS is equal to what? The three angles inside of a triangle add up to what? 180. Does anybody know why I gave these two angles 3-letter names instead of just a 1-letter name? Yeah, it could be either triangle. If I just say angle S, I don't know if that means this angle right here or if that means this angle over here. So I have to give it a 3-letter name so that I'm very specific. All right, let's substitute in what we've got. What can I put in the place of the measure of angle T? X. That is X degrees. Plus angle TSV. Here's T up to S and down to V. How big is that angle? 78 degrees.
So how do you know that TSV is 78 degrees?
Let's go look at it again on the picture. Here's T up to S and down to V. Do you see where it's making that turn?
Yes.
That's the angle that we're looking for. Yep, and we said that that angle was corresponding to RVS on the other triangle because of that triangle congruence statement. Remember, when an angle has a 3-letter name, where it makes the turn is the angle that it's talking about there, which will always be the middle letter in the 3-letter name.
What's the middle letter?
Right there.
Oh,
I've highlighted it, S. That's the vertex. That's where the turn is happening. All right, and then we have the measure of angle TVS. Let's go find TVS on the picture. Here's T over to V and up to S. Do you see where it's making the turn? What is the angle where it's making the turn? 90 degrees. So that's what I substitute in right here. Bring down my plus sign. And that's all equal to 180 degrees. Do I have any like terms to combine? Yes, 78 and 90 combined to give me what? 168, so x degrees plus 168 degrees equals 180 degrees. Then we subtract 168 from both sides. And we get what for x? 12. X equals 12 degrees. So that's x. We were also asked to find y. Where do you see y in the picture? What'd you say? Segment RS, right here. That has 2y minus 1. What does that correspond to on the other triangle? Which one? I heard two different answers.
TS.
TS. Are those marked as being congruent? No, then they're not corresponding.
Oh, RV.
TV.
Wait, how?
Two congruence marks. Two congruence marks. If you look back at the triangle congruence statement, RS was the first two letters. TV was the first two letters. You have to match up those corresponding pieces. Only the corresponding pieces are congruent. You cannot just go based on appearances either. TV is a length of 24. We know that segment RS is congruent to segment TV from the congruence statement. That's what we use to mark up our triangles. So the length of segment RS is equal to the length of segment TV. What do I put in for the length of RS? 2y minus 1. In the length of TV, 24. Then I add 1 to both sides to get 2y by itself. And that gives me 2y equals what? 25. 2y equals 25. Then we divide both sides by 2. What is 25 divided by 2? So y is 12.5. Nicely done. All right, let's go look at number 7 next. Flip over to page 5. First thing I notice in this problem is the triangle congruence statement that they gave me. So just like on the last problem, the first thing I'm going to do is go and mark up those two triangles with their congruences. Can somebody give me a pair of angles that would be corresponding and therefore congruent? D and B. B is the middle letter. D is the middle letter. Again, we always have to go back to the triangle congruence statement. So angle D and angle B. Do we know how big either one of those angles is? Yeah, one of them is how big? 38 degrees. So how big's the other one? 38 degrees. Let's add that to our picture. According to the triangle congruence statement, what is another pair of corresponding and therefore congruent angles? A and E, first letter, first letter. So angle A is a right angle. And angle E is also a right angle. Right angles are how big? 90 degrees. All right, let's go back to our triangle congruence statement. What other two angles would be corresponding and therefore congruent? C and C. Well, that's confusing. When I come over here and look at the picture, here's C. So I got to be a little bit more specific. This is saying that angle ACB, this angle right here, is congruent to angle DCE. What kind of angles are those? Those are vertical angles, and vertical angles are always congruent. So this angle right here is congruent to this angle right here. All right, now let's mark up our sides that are congruent. Give me a pair of corresponding and therefore congruent sides. AB and ED, first two letters, first two letters. AB is right up here. ED is right down here. What's another pair of corresponding and therefore congruent sides? BC and DC, last two letters, last two letters. BC would be this side over here. DC would be this side right here. All right. Last pair of corresponding and therefore congruent sides. AC, first and last letter, and EC, first and last letter. AC is congruent to EC. Now that we have our triangles all marked up with their congruences, we can come in here and find the values for X and for Y. Let's see if we can figure out X first. Where's X in the picture? Segment AB right here. It's 3x minus 10. And we said that segment AB was corresponding and therefore congruent to which other segment? ED or DE. That is 20 yards. All right, so I have that segment AB is congruent to segment DE or ED. It doesn't matter the letter order when you're writing a segment name. So the length of segment AB is equal to the length of segment DE. How big is segment AB? For AB? 3x minus 10. And segment DE? 20 yards. Now I want to solve this for X, so I'm going to add 10 to both sides. 20 plus 10 gives me what? Gives me 30. So I have 3x equals 30, which means X is how big? X is 10. We divide both sides by 3. We get that X is 10. All right. And now we still need to find Y. Where is Y? Angle ACB right here. Yes. Do we know how big the corresponding angle on the other triangle is? No. Then I got to find some other way of figuring this out. If I stay just inside this triangle, do I have enough information to figure out Y? Yeah. Yes. I have that angle A plus angle B plus angle ACB is equal to 180 degrees. How big's angle A? 90 degrees, so I'm going to put 90 in the place of angle A. Plus, how big is angle B? 38 degrees, so we're going to put 38 in the place of B. Plus, what do we put in for ACB? Y equals 180. So we're going to combine our like terms together. I've got 90 and 38 that I can combine together to give me what? 128. So 128 degrees plus Y equals 180 degrees. And then I subtract 128 from both sides. And what do we get for Y? 52. Y equals 52. Absolutely beautiful. All right. Just below this problem, there's some information here. It's called the third angles theorem. The third angles theorem tells me if I have two angles of one triangle that are congruent to two angles of a second triangle. If you look at the picture, angles C and K are congruent. Angles B and J are congruent. So two angles of one triangle congruent to two angles of another triangle. Then the third angles of the triangles are congruent. So angle L, this angle right here, or sorry, angle A and angle L, this angle right here, have to be congruent to each other. Must be congruent. Because I know if I take angle A plus the measure of angle B plus the measure of angle C, that would all have to add up to how much? That would have to add up to 180 degrees. And if I look at the other triangle, angle L plus the measure of angle J plus the measure of angle K would also have to add up to what? Would have to add up to 180 degrees. Well, in the two equations, this part is the same, right? 180 is the same as 180. And what did we say about angles C and K? They are congruent, so that means they are the same. And what did we say about angles B and J? They're also congruent, so those would also be the same. So if the 180s, the piece after the equal sign, is the same, angles C and K are the same, angles B and J are the same, then these two angles must also be the same. Everything else about the equations are the same, so those last pieces there would have to be the same as each other. So far, so good? All right. Let's use this in a couple examples. Let's look at example number 8. It says, Aika is folding origami dragons for a party she is hosting. Triangle ABD is congruent to triangle CBD. Angle A, or sorry, yeah, let's mark up our corresponding congruent parts before I get ahead of myself. According to the congruent statement, angle A is congruent to what? Angle C. Angle A would be right here. Angle C would be right here. What's another pair of corresponding congruent angles? B and B. Well, that's kind of weird. Let's look at this. That would be angle ABD, that angle there, and angle CBD, this angle right here. Those two angles would have to be congruent to each other. And then what's already marked as being congruent? Yep, we've got two right angles on either side of the fold in this piece of paper. It tells me that angle BAD is 58 degrees. Angle BAD. Do you guys see where that turn is happening?
Yeah, A.
It's right at A. That's 58 degrees. well, I have these two angles in this triangle, 90 and 58. So what does that mean about these two angles over here? It's going to be 90 and 58. So we have a 58-degree angle here. These two angles down here are congruent to each other. Let's see what we're supposed to find in the problem. It says find the measure of angle CBD. CBD, that's what I have gone over in purple right here. CBD, this is the thing that we're supposed to find. Do I have enough information staying just inside my triangle to figure that out? Yes, because the three angles are supposed to add up to 180. So I can take my 90-degree angle plus my 58-degree angle plus the measure of angle CBD and set that equal to 180 degrees. Combine some like terms together here. What do I get when I combine 90 and 58 together? 148 plus the measure of angle CBD is equal to 180. Then I minus 148 from both sides. What is 180 minus 148? 32. So angle CBD is 32 degrees. Nicely done. All right. Let's look at number 9 down at the bottom of the page. What kind of a shape do we have in number 9? We have some triangles. What would you call that object? It's a kite. It says the kite shown is made of two congruent triangles. The measure of angle BAD and BCD, those are both 45 degrees. So BAD, do you guys see where that turn is happening? That right there is 45 degrees. And BCD would be this one right over here. This is also 45 degrees. What do they want me to find? ABD. Oh, that color's not going to show up at all. A up to B down to D. They want me to find this angle up here at the top. Do I have enough information to figure that out? Yes. Tell me how to set this up. (45 plus 90 plus the measurement of angle ABD is equal to 180 degrees. We need to combine some like terms together right here, 45 and 90. What do I get when I combine those two? 135 plus the measure of angle ABD is equal to 180 degrees. I'm going to subtract 135 from both sides. And so that means the measure of angle ABD would be how big? 45 degrees. Fantastic. We're going to flip the page. We're going to do just a little bit on this page. We'll be about halfway down. We're going to do numbers 1 and 2 on the next page. And then we're going to stop for today. All right, so we have the isosceles triangle theorem. And then we have the isosceles triangle theorem converse, so where we switch it around the other way. The isosceles triangle theorem says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. And we call the angles opposite those sides the base angles. All right, so I want to draw a picture of what this is saying here. If I have a triangle and two of my sides are congruent to each other, that makes it an isosceles triangle. Because two sides are congruent, that means two angles are congruent. And specifically, the two angles that are congruent are the ones that are across, opposite these congruent sides. So I have to follow them over to the opposite corner, and that's how I find my congruent angles. So these two angles right here would be the base angles. The isosceles triangle theorem converse says if I have two angles in a triangle that are congruent, then the sides opposite those angles are congruent. And again, the two angles that are congruent get called the base angles. So let's draw another picture here. If I have two angles that are congruent in my triangle, that means two of the sides are congruent. The two sides that are congruent are the ones that I get to by going from a congruent angle to the opposite side of the triangle. From one of the congruent angles to the opposite sides of the triangle. My congruent angles are called the base angles. You guys ready to try a problem using this?
Yes.
All right. Fair enough. That sounds very fair. All right, we are going to find x and y here. How many places do you guys see x? 3. 1, 2, 3. I can't set all 3 of them equal, so I'm kind of stuck for a minute. How many places do you see y, though? Just one spot. I think that would be an easier thing for us to find first, because there's only one of them. Do we know the other 2 angles inside this triangle? We know one of them. What's the other angle that we know? What do we call this kind of an angle here? Exterior. There's an exterior angle. So what would we call these 2 angles in relationship to that exterior angle? Remote. These are remote interior angles. And my exterior angles theorem tells me that that exterior angle, which is 104 degrees, is equal to the sum of the 2 remote interior angles. So sum means to add, so y plus 28 degrees. So what do I need to do to find y then? Minus 28 on both sides. What is 104 minus 28? $76. So y is 76. I'm going to add that into my picture.
Why did we subtract that from y more specifically?
Because that's the size of the exterior angle. The exterior angles theorem says my exterior angle is equal to the sum of my 2 remote interior angles.
Okay.
So we take the exterior angle and set it equal to the 2 remote interior angles added together. All right. Do we know what kind of triangle we're looking at here? No. I don't have enough information. I need to know about that third angle, because right now I don't know whether it's isosceles or scalene. I know it can't be equilateral. Why? All the angles would have to be the same to be equilateral, and the angles, these 2 angles aren't the same. What do we call this special angle pair right here? A linear pair. And a linear pair always adds up to how much? 180. So I'm going to do 180 minus that 104 that we have there so that I can figure out how big the linear pair angle is. What is 180 minus 104? 76 degrees. So this angle right here is 76 degrees. So what kind of triangle is this? It is acute. That's not going to help me solve this. It's isosceles. How do we know this is an isosceles triangle? There's 2 congruent angles, and that means there are 2 congruent sides. So this is an isosceles triangle. I need to figure out which sides it is that are congruent so that I can set them equal. What did we write down up above? Which sides are congruent? The ones that are opposite my congruent angles. So one of my 76 degree angles is up here by y. I'm going to follow that to the opposite side. This 8x minus 18 is one of my 2 congruent sides. Where's the other congruent side? 76 degrees is the other congruent angle. Where's the other congruent side? 6x minus 2, right over here. It is opposite that congruent angle. So these are the 2 sides that we are going to set equal. 8x minus 18 equals 6x minus 2. And we can solve this now for x. I'm going to subtract 6x from both sides. What is 8x minus 6x? 2x. 2x minus 18 equals negative 2. Guys, we're not quite done yet. Please stop packing up. We're going to add 18 to both sides. What is negative 2 plus 18? 16. And then we divide both sides by 2, which means x is 8. Nicely done. That is where we're going to stop for today. Don't forget, you guys have homework due tomorrow. Something I want to point out on your homework. On the homework, the first 2 problems, you are given a lot of space for the first 2 problems. Because what I want is for you to identify all the congruent corresponding parts. So I need a list of all the corresponding angles that are congruent. I need a list of all the corresponding sides that are congruent. And then I want a triangle congruent statement. This is like number 2 on page 3 in your notes. Same thing for number 5. I need a list of the corresponding congruent sides. I need a list of the corresponding congruent angles. And I need a triangle congruent statement. Again, just like number 2 on page 3 in your notes.